Hey guys, I am Pulkit, co-founder of Vedantu, and I am your maths master teacher as well. And today we are doing matrices. We are starting the portion for class 12th where we will learn the entire topics at the most basic level at a very relaxed pace, and slowly will increase our level to JEE mains and advanced as well. But my sessions will be at a relaxed pace, at a basic level, covering your NCERT, not leaving anything behind, right? The idea is that after my classes, you don't have to go and revise the concept again from any book. After that, just go on solving the problems, end of the story. And I will want you to make the notes with me as well. So let's start matrices. So bachcho, matrices has been increasing its weightage with time over the years in the examinations. Why? Because matrices is used a lot in computer science. When we build algorithms or the coding, the use of matrices is very, very important there. And since the world is all computational, the world is all full of computer science applications, this topic automatically becomes very, very important as well. Alright, so talking about the weightage, in my previous session I talked about it, but let me talk about it once again. So in board examination, matrices and determinants come for 10 marks, matrices 5, determinants 10 out of 80 marks. As far as the JEE is concerned, typically we have seen 2 to 3 problems in JEE mains, approximately 8 marks. That is 2 questions out of 120 marks, and in JEE advanced, approximately 5 to 10% of the entire maths paper, right, in terms of marks. That is in paper 1 and paper 2 of JEE advanced, right? So it's a fairly important topic. The important thing is it is very scoring, because the things are straightforward. In today's class, it will be relaxed, lots of definitions today. This is what we are going to do. Matrix, the definition of it. What is order of a matrix? Let's get it very, very clear in our minds. What is row? What is column? How to find out the order? What are the problems which come related to that? Type of matrices, all the types of matrices. What is a square matrix, row matrix, column matrix, so on and so forth, right? Diagonal matrix, scalar matrix, so many types of definitions. Equality of matrices. When do we say two matrices are equal? And finally, the addition of matrices. And then we will build on further in the next subsequent classes. This is the target for today. Let's look at some of the matrices. So what is a matrix, right? It is the collection of multiple elements put together in the rectangular array, right? So look at this. So is this a matrix? Yes, because 6 elements are put together in this rectangular formation, right? Similarly, look at this. 9 elements are put together in a rectangular formation, and here how many elements are there? 6. There are certain rows and certain columns in all these matrices. Remember very carefully, how do we represent it? It is represented by, just a minute, bacho. Yeah, so it is represented by a box. Remember, the box has these 2 coming out. If these are not there, it becomes a determinant. Simply this is a determinant, this is a matrix, right? And look at the order of all these. What is the order? First of all, let's see, these are what we call as rows. Bacho, these are the rows. So how many rows are there in this particular matrix? There are 3 rows. And how many columns are there? Bacho, these are the columns. These are the columns. So how many columns are there? 2 columns are there, right? So 3 rows. This is the row 1, this is the row 2, and this is the row 3. And the columns, so this is the column, this is column 1, this is column 2. So how many rows? 3 rows by 2 columns. Always remember, we always write as row followed by column. RC, row, column, right? Look at this. How many rows are there? Row 1, this is the first row, this is the second row, and this is the third row, right? So here we have 3 rows 3 rows, and how many columns are there? 1, 2, 3 columns are there. So it's a 3 by 3 matrix, 3 rows and 3 columns. And what about this? There are 2 rows in this, check, 2 rows, and how many columns are there? 3 columns are there. So 2 rows, 3 columns, 2 rows, 3 columns. It's a 2 by 3 matrix, right? And this is exactly what we call as the order as well. Look at this. This represents the order of this particular matrix. All right. Now, let us define it the way its definition is given in your book. What does it say? A matrix is an ordered rectangular array of numbers or functions. Let's come back to the previous screen. Can we only put the numbers here? No. You can actually put a function also here, right? For example, sin x plus 2, it's a function. 10x, it's a function. So, inside a matrix, I can put a number or I can put a function as well. Remember, I can put real numbers, complex numbers, whatever numbers. So, real number, complex number, function, number, irrational number, integer, you can input anything inside a matrix. All right, no problem. So this is, again, read it. So matrix is an ordered rectangular array of numbers or functions. The numbers or the functions are called the elements. What are all these called? These are called the elements of the matrix, right? Cool. Now also understand one more important thing here, which is see, as I told you, these are the rows, right? And these are the columns, right? These are the columns. So like we do in the coordinate geometry, we can also represent any element in this particular matrix with its row and the column number, right? So let's look at it with this example here. Look at this very carefully. I have drawn it for you. Let's see. So this is the first row. Why am I spending time here? Because once this is clear, everything else starts becoming very simple. I've seen students getting confused with this. Sir, what is row? What is column? It gets all jumbled up in the brain. So let's sort it out once and for all here. So this is row 1. This is the first row. So this, the first number in all these elements represent the row number, right? So see, all are 1. It means all the elements are in the row 1. In this case, it is the second row. See, all are 2. The first number is always 2. Second row. This is the ith row. Some 1, 2, 3, 4, some ith number of row here. So all the first numbers are I, and the last one is m, right? So this is the mth row. So do you realize that the number of rows, if I represent the number of row by a variable I, this I, can I say, takes numbers from 1, it starts from the row number 1, so I can take value from 1 and the highest value it is taking is m. So how many rows are there? There are m rows. Row 1, row 2, row 3, row ith, row mth row, right? Now similarly look at the column. So look at the column. This is the first column. Column is represented by the yellow number. So see, the yellow number, the first column, second column, third column, jth column. So this is the variable j. Let's say this is the jth column, right? And this is the nth column. This is the nth column, right? So how many columns are there? N columns are there. So if j represents the number of the column, then j takes value between the column number 1 to the column number n. Does that make sense? It makes sense, right? Clear? So this is very simple. Now let's go to any particular element. Look at this. This element. This element has the row number 2. It is in the second row and it is in the third column. 1, 2, 3. Row number 1, 2. So row 2, column 3. This is similarly, this is, what is this? This is ith row and jth column. Clear all of you? So this is the most general element Aij. So actually I can represent the matrix, this entire matrix A. I usually represent the matrix bachcho with a capital letter. So this entire huge thing, the huge rectangular array of elements, I can give it a name, a matrix A, and in short I can represent this as, in the same kind of brackets as we put the matrix in, let's put a general element Aij, right, where I represent the number of rows which is m, and j represents the column number, and total number of columns are n, right. So matrix A is a collection of all the elements Aij, where the number of rows are m and the number of columns are n, or the order of this matrix is m into n. Got it? Clear? Any element? Now you can tell any element. So this is A13, 1 row, 3rd column, A22, 2nd row, 2nd column, AM2, mth row, 2nd column, AMN, mth row, nth column. Great, super. I hope this is super clear to all of you. Now let's come here. If the element, now look at this, some basic problems that you will see on the matrix which we can create with our study till now. What have we learned bachcho till now? Simply how to represent a matrix. These kind of square brackets, right? These kind of brackets. Put the elements, rows, columns. That's it, simple. Now let's look at this question. It says if the element in the ith row, it says, look, if the element in the ith row and the jth column of a 2 into 3 matrix, by the way, what is a 2 into 3 matrix? Let's first make it. It has how many rows, bachcho? 2 rows. There are 2 rows in this, right? And how many columns will be there? So there will be 3 columns. Column 1, column 2, column 3 for your representation. 2 by 3. 2 by 3 matrix, right? Its name is A. Its name is A. And the element in the ith row and the jth column is given by I plus, so it has been given a formula. Aij is given by I plus 2j divided by 2. Alright. So I represents number of rows. So I lies between, bachcho, I lies between, the rows are 2, 1 say 2, j column, so 3. Clear? Now let's keep giving them values and keep finding the element. So what is the first element? This is, can I write it as A11, first row, first column, first row, second column, first row, third column, second row, first column, second row, second column, second row, third column. Now let's find out their values. What is A11, bachcho? Put I1, J1. What will it be? 3 by 2. So this will be 3 by 2. What is A12? Do it all of you. A12, first row, second column, 1, 2 into 2, 4, 4 plus 1, 5, 5 by 2. If I am not wrong, you can check, right? And similarly, what is A13? A13 is I1. This is 3, 3 to 6 plus 1, 7, 7 by 2. Right? Clear? Let's keep making the matrix as well. So 3 by 2, 5 by 2, 7 by 2. Now let's get down the second row elements. What will that be? Let's put the value A21, A21. Now row 2, column 1. 2 plus 2, 4. 4 by 2 is 2. So this is 2. This is 2. Right? You're getting the question, right? So they have given the formula to find out every element for any row, any column in the 2 by 3 matrix, right? Now let's find out A to 2. We are finding A to 2 now. Let's put A, I and J both 2. So 2 plus 2 into 2, 4. 4 plus 2, 6. 6 by 2, 3. 3. And last one is A, 2, 3. Second row, third column. So I2, this is 3. So let's look at this, bachcho. Now, these are the questions which also tell you at a very basic level why matrix is important, why matrices are important, because it helps us represent a big array of information in a very structured way. So what it says, read this. Consider the following information regarding number of men and women workers in 3 factories, 1, 2 and 3. So there are 3 factories. So this represents factories. So factories 1, 2, 3. The number of workers in that factories are 30 men workers in the factory 1 and women workers are 25. Then factory 2, 25, 31, 27, 26. Can you represent this information in the matrix? Yes, very simply. So what you can do, you can simply create a matrix, right, with 3 rows and 2 columns, 30, 25, 27, and the second one is 25, 31, 26. So imagine if there was a computer program where you have to input this information, and imagine there's only 3 factories. Imagine there are thousands of factories. So you can simply put the information like this and just tell the program that the row represents the factory number, the row represents the factory number, and the column represents, the first column represents the man and the second column represents the woman working in a particular factory, right? If you give this information to the computer program, and you can then create multiple functions around it in writing that program, and that is why matrices become very, very important in the computer programming, because you can input huge amount of data zook in a single shot and then can define it, and the program can keep taking the values as per the requirement of that program or that algorithm. All right, cool. So let's move ahead. So you can represent this information in the 3 into 2 matrix, 3 rows, 2 columns matrix, right? So just a quick mind map. I'll keep giving mind maps all throughout this class. So this mind map tells you that these are the rows, right? Can you see the colors? So ABC, 1 row. This is row 1, row 2, row 3. This is the column, column 1, column 2, column 3, right? Elements A to I are the elements. Number of elements, this is for example, this is a 3 into 3 matrix. If the matrix is M into N, bachcho, how many elements will be there? Number of elements, remember, number of elements will always be equal to the number of rows into number of columns. Pretty obvious, right? The number of rows multiplied by number of columns will give you all the number of elements. For example, 3 rows, 3 columns, 3 into 3, you will see 9 elements in this. All right. So 9 are the number of elements. What is the order? You read the order as 3. Don't read it as 3 into 3. How will you read this? As 3 by 3. The order is read as M by N. M by N is the order of the matrix. This is what we have studied till now. Let's move ahead. So we are done with the basic definition of it. We understand the order of it. Now let's try to study what are different types of matrices. So very simple. This is, so as I said, today's class is simple definitions for your NCERT level problem solving. So after this class, you'll be super sorted for your boards, for all your basics, and ready to level up in my upcoming sessions for JEE Mains and JEE Advanced. All right, chalo. So let's look at this. What is column matrix? Simple, in which there is just one column. There is what? Only one column, right? So this is the matrix where only one column is there. Can you tell me the order of this? Can you tell me the order of this? How many rows are there? Row 1, 2, 3, 4. 4 are the rows, 1 is the column. The column is one column. So this is the order is 4 into 1 is the order. The order is 4 into 1. In general, can I write the order of the column matrix as, for example, m into 1? Can I write this as m into 1? This, you can have m number of rows, right? But m by 1. So when I say m by 1, the column for sure is 1. And when the column is 1, it is a column matrix. In this particular example, it is a 4 by 1 matrix. Column is 1. Similarly, what is the row matrix? When there is just one row. Just one row, right? So how many rows are there? Just there is one row. Columns can be whatever number of columns. It doesn't matter. Columns can be n number. N number. So can I write this as, in this particular case, row is 1. Number of columns are 1, 2, 3, 4. This is 1 by 4. Important thing to notice that the rows is 1. Can I say that in the basic definition, so a matrix defined by all the elements bij such that the order is 1 into say n, 1 by n, not into, 1 by n, right? Then since this is 1, since the row is 1, it is a row matrix. One row, one column. Clear? This is pretty simple, nothing special here. Now the most important is the square matrix. Square matrix leads to everything else. For example, the entire chapter of determinants is defined for the square looking matrix, right? So square matrix is the most important one. Look here. So square matrix will have what? The rows and the columns as same. Can you see how many rows and columns are here? There are 3 rows and 3 columns. So it's a 3 by 3 matrix. In general, can I say Aij? A matrix A is a set of, or is a collection of all the elements Aij in the matrix such that its order is, say, m by m. Both should be same. Both should be same for it to be a square matrix. Equal number of rows, same number of rows and columns, as simple as that. The definition is a matrix in which the number of rows are equal to the number of columns is said to be a square matrix. Thus, an m by n matrix is said to be square matrix if m is equal to n. If m is equal to n, right? It's a square matrix, very simple. And what is its order, bachcho? What is its order? Rather than saying m by m, you can simply say square matrix of order m. It's understood that it is m by m. If you say square matrix of order m, it simply means yes, rows and columns both are same and both are equal to m. So it's m by m actually. In short, you call it square matrix of order m. End of the story. Alright, chalo, let's move ahead. Now, so in a square matrix, there is one special thing which is defined, and it is defined only for the square matrix, and that is diagonal. So remember, diagonal is only defined for square matrix. So you can note it down if you are noting it down with me. Diagonals are only defined for square matrices. And what is a diagonal? Start from the first row, first column element, and then keep coming till the last row and last column element, right? So this is, in this case, A11, this is A33. This is 3 by 3 matrix you can easily imagine the diagonal here, right? So how do we represent this? Can you see very carefully? This is A11. What will be this? This is A11. This is A22. And what is this? This is A33. Can you now write a definition for it? So basically, what is a diagonal? A diagonal basically is the collection of all the elements A11, A22, A33, A44 till A and N in a square matrix, right? So in the diagonal, all the elements will have the same row number, same column number, 11, 22, 33, 44, 55 till mm. All right, cool. So this is the diagonal matrix. I hope you get it. Now diagonal matrix now leads to multiple types of definitions. But first of all, the first definition is the diagonal matrix. So bachcho, where did we start from? We started with square matrix. In the square matrix, you can define a diagonal. Now, if all the elements other than diagonal are 0, we call it diagonal matrix. So starting was square matrix. Now everything that I am going to define now is true for square matrices only, right? So a square matrix, this is the diagonal. If all the elements other than diagonal are 0, we call it a diagonal matrix. Simple, very clear, right? So this is a 3 by 3 matrix. All the elements other than diagonal is 0. We call it diagonal matrix order 3. Diagonal matrix order 2. It means all the elements other than the diagonal are 0. Can I write a single unit? Yes, you can also write this as, say for example, any number. Is this a diagonal matrix? Yes, it is a diagonal matrix as well of a single element, right? So a square matrix B defined as all the elements Bij in the M into M matrix is said to be diagonal matrix if all its non-diagonal elements are 0. All non-diagonal elements are 0. That is, matrix B is said to be diagonal matrix if Bij all the elements are 0. Which ones? For which I is not equal to j. Did you understand? These are the elements where I and j are equal. So in this, I and j are equal to 1, I and j are equal to 2, I and j are equal to 3. For all other elements, I and j are not equal. If they are not equal, they should be 0. They should better be 0 for diagonal matrix. Only the ones where I, j are equal, they are non-zero. Alright? Okay? They can be 0 by the way as well. These can be 0 as well, right? But others are definitely 0. Cool. Now let's come to the scalar matrix. So we started with square. In square we saw what is a diagonal. Now based on the diagonal, right? If all the elements other than diagonal are 0, diagonal matrix. Now in the diagonal matrix, if all the elements are equal, we call it scalar matrix. So if all the diagonal elements are equal, if all the diagonal elements are equal, we call it a scalar matrix. Simple. So scalar matrix is a diagonal matrix. Scalar matrix is a diagonal matrix. Just that all the elements are equal. Scalar matrix. Simple. So what's the definition? That Bij equal to 0 if I is not equal to j. All elements other than diagonal are 0, and all the diagonal elements, when I is equal to j, it means diagonal elements and they are equal to same number k. Then it is a scalar matrix. Got it? I think it's clear to all of you. Now let's come to the identity matrix. So now if in the scalar matrix, if all the elements are actually becoming equal to 1, in simple words, if this K becomes equal to 1, very simple, it becomes identity. It becomes identity matrix, right? So if all become equal to 1, we call it identity matrix. We call it identity matrix. Okay? So how is the flow happening? We started with diagonal matrix. In diagonal matrix, if all the elements are of all the diagonal elements are equal, it became a scalar. If in the scalar all the elements of the diagonal which are equal, if they take the value 1, they become identity. Very simple. All are actually, so scalar and identity are actually diagonal matrices. All elements equal of the diagonal, and those elements which are equal, they take the value 1, it becomes identity. Simple as that. In short, we represent the identity matrix also as I. For example, this order is 3 by 3, order is 2 by 2, order is 1 by 1, right? So how do we represent that? We in short call this as, for example, this one, we call this as I3. Identity matrix of order 3, identity matrix of order 2, identity matrix of order 1, in short, right? Because what else can it be? Identity matrix of order 3 will obviously be this, there is no other option. Identity matrix of order 2, it has to be this, nothing else. 1 1 1 1 1. Identity matrix of order 1, it has to be this, nothing else, right? Simple. So we have seen all the types of matrices. Have we? No. One is left. Zero matrix. Till now, what we studied in terms of the diagonal matrices or the scalar or the identity, all were square matrices. Now we are talking about a zero matrix. What is a zero matrix? When all the elements are 0. I don't care about the number of rows and number of columns. Just that all elements should be 0. End of the story. 0. All are 0. All are 0. All are 0. It need not be a square matrix. It can be any damn matrix. But if all the elements are 0, it is a zero matrix. A matrix is said to be 0 or null matrix if all its elements are 0, as simple as that. Clear? So we can move ahead. Now this is your mental map. As I said, I'll keep giving you mental maps in this particular chapter. So look at this mental map. Can you tell me, can you fill in the blank? Very quickly, can you do it? Fast. This is what? Only one column. We call it column matrix. Agree? Can you write it yourself? Now, number of rows is equal to number of columns. Square matrix. Number of rows is not equal to number of columns. Not a square matrix, it's a rectangular matrix. Right? It's not a square matrix, it's a rectangular matrix. Now, number of rows is only 1. We call it row matrix. All non-diagonal elements are 0. Right? So only the diagonal elements are remaining, rest are 0. So what do we call it? We call it diagonal matrix. But in the diagonal matrix, if all the elements become equal, we call it scalar matrix. If the value k in the scalar matrix, when all become equal, if that value is actually 1, so, or in simple words, if all the diagonal elements take value 1, we call it identity matrix. If all are 0, we call it null matrix or the zero matrix. That's it. This is what we have studied till now. Clear? Simple. So this map should be enough for you to revise in just few minutes, few seconds. Cool? Is that clear? Should we move ahead? Now, so what we have done, we have understood matrix, we have understood order, we have seen all types of matrices. Now let us see what is equality of a matrix. Now let us see what is equality of a matrix. When do we say two matrices are equal? Very simple. We say two matrices are equal when their corresponding elements are also equal. First of all, for the equality of matrices, their order should be same. So we are talking about these two matrices. Their orders are 2 by 2, 2 by 2. So order should be same. If the order is same, then look at the corresponding. See, this should be equal, this should be equal, this should be equal, and this should be equal. All should be equal. So are these two equal? Yes, these two are equal. Everything is same. Order is the same. Corresponding row column wala elements should also be the same. Similarly, are these two equal? What do you think? Elements are the same, but are they at the exact same position? No. For example, 3, 2. 2, 3. No. 0, 0. Yes. 1, 1. Yes. But even if the 1 is not equal, then it's not an equal matrix, right? So we say this is not equal. This is equal. Clear? So order should be same and the corresponding element should also be same. For example, if this is an equation, it's a matrix equation for example. Can you tell me the values of x, a, y, b, z, c? Can you tell me the value? If these two matrices are equal, their orders are same, 3 row 2 columns, 3 row 2 columns, 3 by 2, 3 by 2, yes. Corresponding value should be same, x must be equal to 3 by 2, a must be equal to 0 and so on. So x is equal to 3 by 2, a must be equal to 0, y must be equal to root 2, right, and b must be equal to minus 5 and so on. Z must be equal to 1 and c must be equal to 2. This is what we call as the equality of the matrix. Is this clear? Right? This is very simple concept, but we can create problems now. Till now there was hardly any problem formation. Now we can start forming the problems. Clear? We'll come to that in a while. So this is the definition. If you write the proper definition of it, if you want to note down, you can. So two matrices A and B with the elements Aij and Bij are said to be equal. First, they should be of the same order. So you need to check the order. Step 1. Step 2. Each element of A is equal to the corresponding element of B. That is, Aij must be equal to Bij for all I and j. So A11 should be equal to B11, A12, B12, A32, B32 and so on. All should be equal corresponding ones. Chalo, let's look at a problem which can be created. It's an NCERT example. To begin with, a simple NCERT example. Let's look at this. See. Equal. They say they are equal. If they are equal, what will you do? Make the corresponding elements equal, as simple as that. So what are the corresponding elements? X plus 3 must be equal to 0, z plus 4 must be equal to 6, 2y minus 7 must be equal to 3y minus 2 and so on. So can we do? Can you do it, all of you? So what will we write? X plus 3 must be equal to 0, z plus 4 must be equal to 6, right, and 2y minus 7. I'm just looking at the first row. 2y minus 7 must be equal to 3y minus 2. So we can start getting some values. For example, I got the value of x. X is minus 3, z will be equal to, z plus 4 is 6, z is equal to 2, right. We can solve this. For example, 2y goes there, 2 comes here, minus 7 plus 2 minus 5. Is this correct? Y equal to minus 5 and so on. Can you keep solving it? Minus 6 same. A minus 1 must be equal to minus 3. So A must be equal to minus 2. What is left? Minus 21 same, 0, 0 same, 0 is equal to 0 must be equal to 2c plus 2 and so on. You can do it. 2c plus 2 is equal to 0. So c must be equal to 2 goes that side, minus 2, minus 1. C is minus 1 and similarly b minus 3. B minus 3 is equal to 2b plus 4 and you can solve it. Alright, clear? So very simple but important to understand because these are the fundamentals and the basics. I think you can do all this now. Alright. So cool. Let's move ahead from here now. So answer is A minus 2, B minus 7, C minus 1, X minus 3, Y minus 5 and Z is equal to 2 as we were doing it. Alright, chalo, let's move ahead. Can you tell me this one? Find the values of A, B, C and D from the following equations. You have to find out the value of A, B, C and D. Can you do it very quickly? Just do the calculations very fast. For the equality, this same, this one and this one same, this one same and this one same. You can do it, I believe. I'm just writing the values and leaving it for you to calculate. 2a plus b is equal to 4, equation 1, and a minus 2b is equal to minus 3. Can you solve these two equations, two corresponding equations? You can solve it, right? What you can do? Write down the first one, write down the second one multiplying by 2, right? It will become 2a minus 4b is equal to minus 6. Why did you do it? Because you wanted to cancel out a. Now you can subtract. So this will be 5b must be equal to 10, b must be equal to 2. The first one. And so two equations, two variables ab. The below ones are the equations in C and D. So 5c minus d is equal to 11 and 4c plus 3d is equal to 24. You can solve this as well. What will you do? Say multiply this one by 3. You can multiply this one by 3. So this will become 15c minus 3d is equal to 33 and you will solve these two equations, right, by adding them. So कितना हो जाएगा? What will this be? This will be 19c if I am not wrong. Cancels out, right? Is this correct? C will be equal to, is this clear? Or you can check the calculations if I have done any mistake here, but just, you got the point, right? Two equations, two variables, solve. Alright? Cool? Chalo. So let's see the answer. So answer is here, A1, B2. So here say A1, B2. A will be come out to be 1. A1, B2. C will come out to be minus 1. Sorry, where is it? A1, B2, C3 and D4. C3 and D4 you can check. Alright, let's move ahead. Now, some more problems which have come in your NCERT books. Let's see. In the matrix this, so let's see the kind of problems which come in the exercises in the NCERT. Okay, let's look at them. Till now, what have we learned? We have learned the types of all the matrices, we have learned the equality of matrices, we have understood the order of the matrices, and we are now seeing some of the problems which come in your NCERT. So a matrix is given 2, 5, 19, minus 7 and so on. What's the order, bachcho? How many rows are there? First row, second row, third row. What is the order? Sorry, what is the column? 1, 2, 3, 4. So can you write down the order? It is 3 row by 4 columns. So 3 row by 4 columns. So order of the matrix is 3 by 4. Alright. Second, the number of, the first one is order of the matrix 3 by 4. Second is the number of elements. Bachcho, what is the number of elements? Number of elements is actually the number of rows multiplied by number of columns. So this will be, number of elements will be 3 multiplied by 4, which is equal to 12. So 12 number of elements, as you can see. 3, 4 times. 3 into 4, 12. Write the elements A13, A21, very simple. What is A13, bachcho? First row, third column. First row, third column, 19. Correct? Just for your understanding, so that there is no confusion. A21, second row, first column. A21, second row, first column, 35. A33, third row, third column. Third row, 1, 2, 3, third column, minus 5. A24, second row, 2 is row, 4 is column. Second row, 1, 2, 3, 4, fourth column, 12. A23, second row, third column. Second row, 1, 2, 3, third column, 5 by 2. Is this clear? Don't make mistake in this, bachcho. This is very basic, but trust me, that's why I'm going slow, because I know this is where you guys make mistakes. That's why. Alright, chalo, let's move ahead. Now, if a matrix has 24 elements, what are the possible orders it can have? What if it has 13 elements? If a matrix has 24 elements, so how can you arrange 24 elements in a rectangular setup is the question, right? In simple words, in how many ways can you write 24? 24 elements is what? It is m into n, which is the row, and this is the column. So number of rows into number of columns should give you the total number of elements, as we have seen. So how many such pairs can you write? So you can write this as, starting with 24 itself, 24 into 1. If you are writing 24 into 1, you should also write 1 into 24. 24 rows, 1 column. 1 row, 24 columns, right? Then second one is 12. So 12 into 2, then 2 into 12. So 12 rows, 2 columns, 2 rows, 12 columns. What can be? I'm reduce, or you can increase the number here. 1, 2, so next will be 3. What gets multiplied by 3 to give you 24? 8. So this should be 3 into 8 as well. Then 4. What's multiplied by 4 gives you 24? 6. So 4 into 6 as well, right? What else is there? 1, 2, 3, 4, 5 is not there. 6 we have already taken, that's it. These are the possibilities. How many possibilities are there? 1, 2, 3, 4, 5, 6, 7, 8. There are these 8 possible ways in which you can represent 24 elements in the form of a matrix. Is that clear, all of you? Right? So what's the answer? Answer is this. So 1 into 24, 12 into 2, sorry, all this, whatever that we have written. Did we miss one? Yes, no we didn't. All are covered, right? Now in the case of the next one, if there are 13 elements, there is only 2 ways to make 13, right? So 13 can be written as either 13 into 1 or as 1 into 13. That's it, only 2 ways are there. No other way. So either 13 rows, imagine 13 rows, only 1 column, or only 1 row, 13 columns, right? So these are the only 2 ways possible. Is that clear? So this is again one variety of problems that you will see. Simple one, but you have to create the cases, right? Only 2 ways in this particular case. Now, another type of NCERT question, find the value of ABCD from this equation. Again same that we have done. Can I leave it to you for you to do. It is exactly the same kind of problem which we did here, right? 4 variables, and how many equations? 4 equations. Yes, same. What will you do? A minus b is equal to -1, that you can solve. So a minus, just a minute, light went off. Yeah, so a minus b is equal to -1, and I'm using this and this equation to calculate a and b. So a minus b is equal to -1 using this one and using this one. So 2a minus b is equal to 0. So from here you will find a and b, and from these two, this one and this one, you will find out c and d. So 2a plus c is equal to 5, 3c plus d is equal to 13, right? So what should you do? From here find a and b, from here find a and b. Once you have found out a, put the value in this, you will get c. Once you have found out c, take its value, put in this, and you will get d. Got it? You can solve it yourself. Row matrix, only one row. Column matrix, only one column. Square matrix, m and n are same, rows and columns are same. Diagonal matrix, if other than diagonal, all the elements are 0. If the diagonal elements become equal, scalar matrix. If the value of all these equal elements in diagonal matrix, if they become equal to 1, identity matrix, right? If all the elements are 0, null matrix. So that was the type. Equality we know. Last concept, addition of matrices, which is very simple. So today we will do addition of matrices. In the next class we will do, today we will also do this. In the next class we will do this in the next class. That is multiplication of matrices, one entire class on this, because this is very important. Okay, now as far as addition is concerned, so let's look at this. In the addition of matrices, bachcho, what we do, we just add the corresponding elements again, right? So first of all, to add the matrices, they should be of the same order. Look at this, 2 rows, 3 columns, 2 rows, 3 columns, 2 rows, 3 columns. Now when you'll add, what will you do, bachcho? You will simply add this plus this. Similarly, this one plus this one plus this one, right? And similarly, this plus this plus this plus this. To give you what? To give you a plus b as, see carefully, the first row, first column is addition of first row, first column elements of both, right? So a11 plus b11. First row, second column of addition matrix is the addition of the elements in first row, second column, first row, second column. That is a12 plus b12. Then similarly a13 plus b13. And then let's talk about the second row. So second row, first column, second row, first column. Second row, second column plus second row, second column of the other one. Second row, third column plus second row, third column of the other one. Now this is what we call as the addition matrix. Bilkul simple as that, right? All you need to do is add the corresponding elements. So for example, if you look at this, what has happened to my slide? I think you can see the numbers. I'll show you. So A is, let me write it for you. A is root 3, 1 minus 1, alright, and then it is 2, 3, 0, and B, you can see, you have to find out A plus B. What is A plus B, bachcho? Can you write it very fast? What will be A plus B? See carefully. What is a plus b? Root 3 plus 2, first row, first column, first row, first column, root 3 plus 2, then 1 plus root 5, first row, third column, first row, third column, minus 1 plus 1, 0. Alright. Second row, always keep talking it to yourself the way I am doing. I am always talking as row and column, row as column, row and column. I am creating a mental map for myself. Okay. So, second row, first column, second row, first column, 2 minus 2, 0. Second row, second column, second row, second column, 3 plus 3, 6. And 0 plus half is half. This is the addition of these two matrices. Is this clear? Pretty simple, right? Now, finally we are coming down to operations of matrices, which we learned just now, which is addition to begin with. This is the definition, same what we have done, right? This is for your notes. Nothing to repeat here, we have just done this. Let's look at more properties of the addition. Bachcho, remember, addition of matrices, like in the case of numbers, it follows two important properties, commutative as well as associative, right? It follows commutative and the associative properties. I'll put it in simple words for you. If you add two matrices, the order does not matter. You do A plus B or you do B plus A, does not matter. You can see easily from here. You add this plus this or you add this plus this. How does that matter? Root 3 plus 2 or 2 plus root 3, both are same. 1 plus root 5 or root 5 plus 1, both are same. Minus 1 plus 1, 0 or 1 plus minus 1, 0, both are same. So, order of addition does not matter. So, hence A plus B is equal to B plus A. And exactly because of that, it is also commutative, sorry, it is also associative in the sense, you add A plus B first and then add it to C, or you add B plus C first and then add it to A. It does not matter. Finally, elements of all these three are going to get added up, right? So, you add these two first, find the matrix, add C to it. You will get the same answer as add B plus C matrix first, find the matrix, add it with the matrix A, you will get the same answer, right? So, it is commutative as well as associative, and as per the proper definition, two more definitions. Existence of additive identity, it means don't go by all this jargons. As simple as that, if you add a matrix to a zero matrix or a null matrix, what you will get is the matrix itself. Obvious. It's obvious, no? Right? For example, if the A matrix is 1, 3, 5, 7, if you add it to the zero matrix of the same order, of course, addition happens only if the orders are same. If you add it to a zero matrix of the same order, what will you get? The same matrix, no? So 1 plus 0, 1, 3 plus 0, 3, 5 plus 0, 5, 7 plus 0, 7. So A plus 0 will give you nothing but A once again, right? So zero matrix is the additive identity of A. In simple words, if A is of the order m by n, then this zero matrix of the order m by n is called the additive identity of the matrix A. Similarly, there also exists additive inverse. In the world of numbers, what was additive inverse? The number with which when you add a number, the answer is 0. So yes, so there exists a matrix A. If we have a matrix A, then there exists a matrix minus A. When you add these two, the answer is null matrix. What is minus A? Now we'll come to that. We'll call it negative of a matrix, right? It's the negative of A. Now to come to negative of A, let us first study one thing. Multiplication of matrix by a scalar. We'll come back to the negative matrix in a while. So, important thing to study here is, if you have a matrix A, bachcho, what we are studying? We have studied addition, we are studying multiplication, not of two matrices, we are studying multiplication of a matrix by a number, by a scalar, not a variable, by a scalar, right? By a scalar. It means if a matrix is given to you, what if I multiply that matrix by a number 3, by a scalar 3? It is as simple as saying multiply all the elements by 3. Simple. So when you are multiplying a matrix by 3, what you are doing? You are multiplying all the elements by the number 3. Can we do that? So the resulting matrix will be 3 into 2, 6, 3 into 1, 3, 3 into 1.5, 4.5, 3 into root 2, 3 root 2, 3, 5, 15, minus 9, 3 into 0, 0, 3 to just 6, 3 3 is a 9. So this is the resulting matrix of multiplying a scalar with a matrix. So if you multiply a matrix by a number k or a scalar k, then all the elements aij will get multiplied by the number k. That's it, simple. So let's take an example. We have done this similar one, you can do it, right? So what is 3a in this case? Can you do it? Same, it's the same, right? So we have done this already. It's an NCERT example, but it leads us to the negative of a matrix. So if you know the multiplication by a scalar, you can now find out the negative. What was the negative here? We studied negative here, right? So let's come to the negative. So if you are given a matrix A, what if I say I need a minus A? Aja? Minus A. So what is minus A? I am actually multiplying. So what is minus A? It is minus 1 multiplied by A. So what is minus A? All the elements will become negative. No, not negative. All the elements will get multiplied by minus 1, right? So if this is A, what will be minus A? Minus A will be give a minus sign or multiply all the elements with a minus 1. So 2 will become minus 2, 3 will become minus 3, x will become minus x, and minus 5 when multiplied by minus 1 will become 5. This is what we call as minus A. Alright, and this is what we call as the negative of a matrix. And we also know now A plus minus A. So if you add this and this, 2 minus 2 0, 3 minus 3 0, x minus x 0, minus 5 plus 5 0. So A plus minus A will give you what? A 0 matrix. Alright, this is exactly what we studied here. It's what we call as existence of additive inverse. Existence of additive inverse means, yes, there exists a matrix which when added to A will give you 0 matrix. And what is that matrix? It is minus A. Clear? Alright, cool. So this is what we have studied. For your quick summary, A plus B, you know what is A plus B if two matrices are given. You know cumulative existence of, you know the properties, associative law, cumulative law, and the existence of the identity, right? Cool. Difference of the matrix, nothing. Difference of the matrix is just like the addition only, right? So if you look at the difference, this is the last property, bachcho. So what is A minus B? Just think of that as A plus minus B, right? If you have to do A plus minus B, that is nothing but A minus B. So when you are subtracting two matrices, you are actually multiplying B with a minus sign and then adding the two. Alright, cool. Clear? Alright, now let's look at an example. Something happened to my slide, but I'll write the matrices here. A is 8, 0, 4, minus 2, 3, 6, and B is given to be 2, minus 2, 4, 2, minus 5, 1. Okay. Question is, can you find out x when it is given 2a plus 3x is equal to 5b? This is your NCERT example. Question is to find out x. Can you find out x? I'll leave the calculation to you, but we'll discuss how you will approach it. Let's look at this. 2a plus 3x is 5b. I have to find out x. I have to find out x. What should I do? Like in algebra, can I take 2a on the other side? Yes, you can. But I'll tell you the exact steps to understand this. So actually what we are doing step by step is, can I add minus 2a to both the sides? So 2a plus 3x, I am adding minus 2a on both the sides. Can I do that? Can I do that? I have added minus 2a on both the sides. But what will happen? This minus 2a and 2a, when they will get added, it will create a null matrix, a zero matrix. It will happen. But what is null matrix plus a matrix? Null matrix, when you add to something, it will give you the same. So basically 0 plus 3x is nothing but 3x is equal to 5b minus 2a. Right? Now can I divide, or I can multiply all by 1 by 3? In simple words, I can divide all the matrices by 3. So this will give you, when I divide by 3, it will give you x is equal to 5 by 3b minus 2 by 3a. This will give you your x matrix. Now how do you find x matrix now? Take the b1, take b, multiply that by 5 by 3. So multiply all the elements by 5 by 3. Right? You will get 5 by 3b. Then take A matrix, multiply all by minus 2 by 3. Right? So multiply all by minus 2 by 3. Add the two, right? I'll write one row, for example, for 5 by 3b minus 2 by 3. Let me write one row for it, right? In the first row, 5 by 3b will be 5 by 3 into 2 minus 2 by 3a minus 2 by 3 into 8. Got it? In single one stroke, you can write down the first row, first column of x now. What will be the x ka second row? Sorry, the first row, second column, 5 by 3b. So multiply that by 5 by 3. So 5 by 3 into minus 2 minus 2 by 3 this. So 2 by 3 into 0, which is 0. Similarly, you can calculate this and this as well. Got it? Is that clear? This is clear, right? You can check out this example from NCERT as well. So again, such questions are pretty common and popular, right? Now, simple properties, nothing special here. We studied addition, we studied the properties of addition, commutative, associative. Then we studied the multiplication with a scalar. Simple properties of multiplication of the scalar. If you are multiplying k with a plus b, it's as simple as saying multiply the matrix A with k, multiply the matrix B with k, add the two matrices. Like you do it in algebra, right? Now, k plus I multiplied by a, right? K plus L, say multiplied by a, it is multiply k with a multiply L with A, add the two, like you do in the bracket open, right? Clear? Alright, so this is simple, nothing special here. It follows the same properties as the properties you have done in your algebra. Alright, cool, let's do a few questions and then that's it. So we have completed the theory, let's do a few problems here. So the number of all possible matrices of order 3 into 3 with each entry 0 or 1. Can somebody tell me the answer? Can you tell the answer? Understand, the number of all possible matrices of order 3 into 3. So the order is 3 into 3. Right? Say A11, A12, A13, second row, first column, third row, first column, third, second, third, third. Just for your visualization. So this is a 3 by 3 matrix. It says each entry can be 0 or 1. So what is the possibility that it has? It can either be 0 or it can be 1. Similarly, this can either be 0 or it can be 1. So can you tell me how many options does, how many options does every element has? 2 options, 2 possibilities. So each element has 2 possibilities. But how many elements are there? 1, 2, 3, 1, 2, 3, 1, 2, 3, 3 into 3, 9. So there are 9 elements and each element has 2 possibilities. So what does it mean? It means first element 2 possibilities, second element 2 possibilities, third element 2 possibilities. How many times? 9 elements 9 times. So this must be 2 raised to power 9, which must be equal to 5, 1 and 2. Yes. There are 512 ways of creating a matrix of 3 by 3 order where each term, each element can either be 0 or be 1. Alright, so the answer bachcho is 5, 1, 2 here. Very nice question. So lots of questions can be created using the order and the possibilities of creating matrices with some rule sets given. Alright, cool. So now I'll end this session and I'll give you some questions that you should do, simple questions. So exercise 3.2 you should do, simple questions of addition. Say for example this, as simple as that. Can you immediately tell me the answer verbally? What will be the answer? Quick. Cos square plus sine square, 1. Sine square plus cos square, 1. Sine square plus cos square, 1. Cos square plus sine square, 1. This is the resulting matrix. And such simple problems to strengthen your basics you should do. So you can either do the NCERT to begin with or you can do R.D. Sharma subjective. At least the solved examples before you jump to the J level problems in this chapter. It doesn't take much time, right? In few hours you should be done with it and then you can go to the J level problems that we will do in our level up sessions. Alright, these are some of the problems. Then these are CBSE PYQs which you can take as your home assignment. From the replay, you can take these questions and you should do it on your own. Right? I'll give you the answer and the solutions in the Telegram group whose description is there in the description. The link is there in the description, and I'll give you more assignments as well on matrices. If you do that, you are sorted at all the levels. Okay, so this is another problem. Another problem. Another one. You can take it from the replay. Right? Cool. And I've given you some slides for the quick summary, right? So we have studied matrix, order, types of matrices, equality, operations on the matrices, addition, multiplication with a scalar, negative of a matrix, and differences of a matrix, right? This is what we did in the memory map when we started this session, right? And this is the memory map of the types of session which will help you revise just like that. Cool. The memory map for the addition, the memory map for the subtraction, right? In the next class, we will study operations on matrices, but which one? The multiplication of matrices, the most important part. And then the transpose of a matrix, symmetric matrices, and the skew symmetric matrices. Alright, on that note, bachcho, keep smiling, be happy, and see you in your next class. And with slowly and steadily, with focus on the basics, we will cover the entire mathematics, and you should come out super strong. Alright, so we will do two types of sessions. One is the basics, which this was, and then the level up ones where we'll increase the level to JEE Mains and Advanced. See you in the next class, bachcho. Bye bye.